Okay, good morning. This is Professor David J. DelosReyes. It's September 7, 2023. Okay, it's the birthday of my father, September 7. Okay. My topic for this morning will be a long video format discussion on college algebra, and this will now be lesson number 54. Okay, let's proceed. So for those of you who are following my college algebra long video format discussion, we are now on lesson number 54. So this is college algebra lesson number 54. The title of the topic will be arithmetic / geometric sequence application problems. It's a verbal problem that involves arithmetic and geometric sequence concepts. Okay, let's proceed with example number 1. Okay, I will try to read the problem. A pre-polling object will fall 16 feet during the first second, 48 feet during the next second, 144 feet during the third second, and so on. What is the total distance the object will pull in 8 seconds if the pattern continue? Okay, this is a problem under a pre-polling body, pre-polling body is actually a body that will accelerate with time, because the given problem says that for the given I will place a distance to be designated by small letter d. So I will be placing distances here for this given problem. D refers to distance traveled by the polling object. So this we got 3 subscript here, 1, 2, 3, meaning d sub 1 is 16 feet. That is after 1 second. The polling object, this will be the path of the polling object, right? On the first second, the distance traveled by the polling object, we assume that it just traveled linearly on simply in the so-called straight line. We neglect a resistance for the meantime. That's another thing. So we assume the pre-polling body in a so-called vacuum. So no air resistance. So the path of the polling object will be straight line. On the first second, it travels 16 feet. And according to the given condition of the problem, on the next second, it travels, is it 16 feet? 48 feet. After another second, okay, it travels 48 feet. Okay? On the third second, meaning after 3 seconds, again, it traveled 144 feet. So initially, per second, 16 feet. Second, it's 48 feet. Third second, it is 144 feet. So actually, if we try to observe the variation in the distance traveled by the polling object, of course, this is under geometric progression. Because if we try to, okay, let's try to bring out first what is required. The problem is what is the total distance the object will pull in 8 seconds, meaning after traveling for 8 seconds, okay, what will be the total distance traveled by the polling object? So what will be d after time t is equal to 8 seconds? I've given these conditions here. D1 is 16 feet after 1 second, D2 is 48 feet after 2 seconds, and D3 will be 144 feet, that is after 3 seconds. Okay? So to bring out the solution of this, if the given problem is under geometric progression, let's try to verify the ratio. The ratio R will be, what do you call this? The thing that is involved here is distance, so it should be ratio for a geometric progression will be distance 2 divided by distance 1 or distance 3 divided by distance 2. If these two are correct, of course, the sequence is under geometric progression. So if we try to check it, it will be 48 over 16 or it will be 144 over 48. And if we try to take the ratio, the value of R is actually 3. Okay? Meaning to say, every second, okay, the distance traveled by the falling object is actually 3 times the original. That's the meaning of this. So using the equation, capital letter S with the subscript N under geometric progression, it should be A1 times the quantity open bracket 1 minus R to the N over 1 minus R close bracket. For this given equation here, we will replace A because A1 is just a representation from our concepts, right? But it could take any value. So A1 is actually the distance here. It should be D1. And the Sn here will be small letter d, distance. Under geometric, S in A1 is just a representation. So if the given problem does not commensurate with S in A1, we replace the designation. So this should be Dn now, right? And they should be D1, right? It's the same. We just change the symbol. The problem is asking what will be the total distance traveled after N. This in here is T, okay, is equal to N, is actually 8 seconds. So by using this formula under geometric, the summation of N terms under geometric progression, what will be the summation of 16 plus 48 plus 144 till 8 seconds? So instead of solving longhand, we could use the formula d sub n will be d sub 1 times the open bracket 1 minus r to the n over 1 minus r. Substituting values. Distance number 1 is actually 16. Right? 1 minus, the ratio, computed value of ratio is 3 to the 8th power over 1 minus 3. So they should be 16, open bracket, 1 minus 3 to the 8th power will be 65, 61 minus 2. And 65, 61 minus 1, this is minus, right? So we subtract 1 here, but the sign should be negative. So it will become 65, 60 negative all over a negative 2. This is multiplied by 16. So a negative over a negative will be positive. Okay, so the ratio of this multiplied by 16, what comes out is 30 to 80, the ratio of this one, times 16. And the value will be 52,480 feet. That is after 8 seconds. The object is actually accelerating because it came from the cloud maybe. So every second it accelerates. It came from 16 feet originally. On the next second, it became, 48 feet. On the third second, it goes to the value 144. So on the 8th second, okay, the total distance traveled by the object is actually 52,480 feet. This is almost 1 mile is 5,280 feet. This is almost 5 miles. This is approximately 5 miles. Right? Because 1 mile is 5,280 feet approximately. Right? 5. This is almost 5 miles. That will be the answer for example number 1. Example number 2 is a little bit controversial. Okay, I will try to read the problem. Am I still on camera? If you pay 950,000, okay, this is not dollar, pesos maybe, for a car and its value depreciates 10% per year, how much will it be worth after 5 years? Cars, when you bought it originally, actually depreciates a year. So the problem is asking if the original price was 950,000. Excuse me? 950,000. And the rate of depreciation is 10% per year. What will be the value of the car after 5 years? Of course, it will lessen in value. If it's a real estate, land, maybe it will not depreciate. It will appreciate. But for cars, whether we like it or not, it will depreciate. Right? So, I will designate P here to be price, and N is equal to 5 years. The depreciation rate is 10% per year. Since P is price, I will place here P sub 1, meaning the original price is 950,000. Or this could be dollar maybe. Assuming this is just an illustration, an example problem. I try to solve this problem by using arithmetic sequence, but I think it does not fall under arithmetic sequence. Okay, so I will be bringing out the solution, the longhand solution. So actually we could visualize it. So I will be placing a graph over here. Then I will mark this graph 0, 1, 2, 3, 4, 5. These are the number of years. Right? So at time t equal to 0, the price of the car was 950,000. Okay? After 1 year, what will be the value? The problem says the rate of depreciation is 10% per year. So 100% is actually 1 minus 10% is 0.1. And 1 minus 0.1 is actually 0.9. So meaning to say, on the second year, this 950,000 will be reduced to 90% value. So if we try to compute the value on the second year, okay, that 950,000 now become 855,000. That's the meaning of the so-called 10% per year depreciation. It is 1 minus 0.1, that will be 0.9. So we will multiply the original price by 0.9 because it depreciates in value 90%, right? No, 10%. So what remains for the value on the second year will be the 90% of the original. So 90% of 950,000 is 855,000. On the second year, okay, that's the first year. On the second year, the value will again depreciate 10%. But the amount that we will be taking is the present worth value. It's not the original value. Okay? We depreciated already this one. So what will be depreciated on the second year is the value on the first year. So this should be 855,000. It says it depreciates 10% per year, right? So again, this is multiplied by 0.9. 855,000 times 0.9, that will be 769,500. So the value on the third year, second year, it's 769,500. If you try to see it came from 950, 855, 769. So actually, we could say that the value actually depreciates, right? On the third year, the value of the third year should be the present value on the second year minus the depreciation. So again, we will multiply 769,500 times 0.9. And on the third year, the amount or the present worth value of the car now will be 692,550. It becoming lesser, right? On the fourth year, okay, again, it will depreciate 10%. Okay, but the value we will be depreciating will be on the fourth year will be the present worth value on the third year. So the present worth value on the third year is 692,550 times 0.9. So on the fourth year, okay, the value now become 623,295. And on the fifth year, this is the one being asked by the problem. What will be the value on the fifth year? Okay, So on the fifth year, okay, again, it will depreciate 10%. But the amount to be depreciated will be the present worth value on the fourth year. So it will be 623,295. Am I still on camera? Times 0.9 because less 10% depreciation. And the value on the fifth year will be 560,695. Oh, imagine this, if this is 20 years, your car has now maybe a negative value. So at least we now know that this 950,000, if the depreciation per year is 10%, after 5 years, that 950,000 is now worth only 560,000. Oh, maybe this is dollars. So the answer for this problem here by using the longhand solution will be 560,695. I think the problem will not be under arithmetic sequence or geometric sequence. So what do we do? Okay, we could use the longhand solution. Okay, that's it, guys. So for those of you who are taking up college algebra, okay, if you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. Okay, this is it. Good morning from Los Angeles, Professor David J. DelosReyes. We'll be discussing lesson 54 the next time around, and I think the topic will be binomial theory. Good morning from Los Angeles, Professor David J. DelosReyes.